Take a look at this strawberry. It's red, right? Vibrant, crimson, unmistakable red. You've known this since you were in kindergarten. It is a fundamental truth of your reality. But here's a thought that might keep you up tonight. What if the sensation in your brain when you look at this fruit is what I would call blue? What if your entire reality is painted in a palette I can't even imagine? But because we both point to this object and use the word red, we never find out. This isn't just a late-night philosophy trope. It's a genuine scientific and neurological mystery called qualia. Today, we're peeling back the layers of the retina to ask, is color actually real, or is it just a private hallucination we all happen to agree on? To understand why we might see things differently, we first have to look at the hardware. Color doesn't actually exist out there in the world. Out there, we just have electromagnetic radiation, waves of energy bouncing off objects. When those waves hit your eye, they land on the retina, which is packed with photoreceptors called cones. Most humans are trichromats. We have 3 types of cones, each tuned to different wavelengths. We have the short wavelength for blue, medium for green, and long for red. When light hits these, they send electrical pulses to the visual cortex. If the signal is mostly from the L cones, your brain screams red. But here's the catch. The hardware isn't identical. Some people have more red cones than green. Others, about 12% of women, might actually be tetrachromats. They have a 4th cone that allows them to see millions of colors the rest of us literally cannot perceive. If our cameras are all calibrated differently, how can the footage in our minds look exactly the same? Let's dive into a classic thought experiment, the inverted spectrum. Imagine a person named Alex. Since birth, Alex's brain has swapped the signals for red and green. When Alex looks at a stop sign, they experience the internal sensation that you would call green. But remember, Alex was taught that the color of a stop sign is called red. Alex goes through life perfectly fine. They stop at red lights, they buy ripe strawberries, and they comment on the beautiful red sunset. There is no physical test, no blood work, no brain scan that can currently prove Alex's internal red is the same as yours. Philosophers call these individual instances of subjective experience qualia. You can describe the physics of a wave, specifically 700 nanometers, but you cannot describe the feeling of the color. It is the ultimate private property. If biology varies and philosophy is a dead end, can language save us? Not exactly. In fact, language suggests we definitely don't see the same world. Take the ancient Greeks. Homer famously described the sea as wine dark. He never used a word for blue. Was the Mediterranean Sea actually purple back then? Probably not. But without a linguistic category for blue, their brains likely processed it as a shade of green or black. Or look at the Himba people of Namibia. They have many words for different types of green that look identical to Westerners, but they don't have a separate word for blue. In tests, they can spot a slightly different shade of green in a circle of identical greens almost instantly, a task that takes us much longer. Our language acts like a filter, grouping colors together. Your brain actually becomes faster at distinguishing colors if you have a specific name for them. If you need proof that we live in different visual worlds, look no further than The Dress. Half the world saw white and gold, the other half saw blue and black. Why? Because our brains were making different assumptions about the lighting. This is called color constancy. If your brain assumed the dress was in a shadow, it subtracted the blue light, leaving you with white and gold. If it assumed the dress was under bright artificial light, it saw blue and black. This proved that color is a calculation, not a fact. Your brain isn't a window, it's an interpreter. It looks at the context, the shadows, and your past experiences to guess what color something is. And we don't all guess the same way. So, do we see different colors? The answer is almost certainly yes. Between our cone distributions, our unique linguistic filters, and the way our brains interpret lighting, no two people are looking at the exact same movie. But maybe that's the beauty of it. We are all locked in our own private galleries, looking at a world that is uniquely ours. We use language to build bridges between these galleries, hoping that when I say, "That's a beautiful blue sky," you're seeing something just as spectacular, even if your blue is my orange. Next time you disagree with someone over a paint swatch or the color of a shirt, don't get frustrated. Just realize you're getting a tiny glimpse into the fact that we're all living in slightly different universes. So, what color are you seeing right now?